All right, so benchmark 19 is I can solve and graph inequalities. And it's important to know the signs less than, greater than, less than or equal to, or greater than or equal to. Make sure you write down these keywords for each one. Those are important to know, especially for the word problems. So if we look at solving inequalities, we solve them just like we would an equation. So we can set up, we still have two sides of our equation, our inequality. So to solve this one, we would divide both sides by 3. So in this case, x would be less than 4. So the way we solve equations is the exact same as solving inequalities. So if we look at the next example, on this one we can subtract 4 on both sides. So we would have x is greater than or equal to 2. So our solution for this one, we can plug in any number greater than 2 or 2 for this one to make sense. For our next example, when we are dividing by a half, it's the same as multiplying by 2. So we can still divide both sides by a half, and x would be less than or equal to -6. So remember, when you divide by a half, it's the same as multiplying by 2. So on our next example, and this is where it gets a little tricky, whenever we divide by a negative number, we have to flip the sign. So in this case, we would have x is less than -3. So in this case, we would flip the sign from greater than to less than, and then this would be our solution. So we just did one-step inequalities. Now we're going to do two-step. And again, those are the same as solving an equation. So when we have a two-step inequality, we start by getting rid of the constants on both sides. So we have 3x is less than 12. And then we would divide both sides by 3 to get x by itself. So x is less than 4. On the next one, we would again start with our constants. So we would subtract 5 on both sides. Those cancel. So we're left with 1/2 x is greater than or equal to 5. And then just like the last one, we would divide. And when we divide by a half, it's the same as multiplying by 2. So x would be greater than or equal to 10. On this one, same thing. We start with our constant, so we can subtract 6 on both sides. So we would have -3x is less than or equal to 6. And then here we have to divide by a negative, so we have to be sure to flip the sign in our answer. So in this case, x is greater than or equal to 2. So we went from less than or equal to greater than or equal to in our solution. Now that we can solve inequalities, we have to graph inequalities. So we'll graph them on a number line, but when we graph them on a number line, we have to either use a closed circle or an open circle. So we're going to use an open circle if we have the less than sign or the greater than sign. And we're going to use a closed circle if we have less than or equal to or greater than or equal to. So let's look at a few examples of that. So here's one where it's already solved and we just have to graph x is less than 3. So on our number line, we would put 3 and a few numbers bigger, a few numbers smaller. And since we have just less than for our sign, we're going to use an open circle on 3. And since x is less than 3, we would shade the numbers less than 3 on our number line. So one way you can check to see if you shade the right way on the number line is plug in a number that you've shaded. So if we plug in 1, 1 is less than 3. That's a true statement. But if we were to plug in 5, 5 is not less than 3. That's not true. So we know we shaded the right way. So let's do one where we have to solve it and then graph it. So again, we solve them just like a 1 or 2 step equation. In this case, we'll divide both sides by 2. so x is less than 5. On our number line, we would put 5 and a few numbers bigger, a few numbers smaller. And since we have just less than, we're going to use an open circle on 5 and shade the numbers less than 5. So if we were to check it, if we plug in 4, 4 is less than 5, and that's the way we shade it, so that makes sense. So on this one, it's a two-step. So we have to start by subtracting 1 on both sides first. So then we would have negative 3x is greater than or equal to 9. Then divide by negative 3. And when we divide by a negative, we flip the sign. So in this case, x is going to be less than negative 3. So on our number line, we would put negative 3, negative 2, negative 1, and then a few numbers smaller. Remember, when you're doing your number line with negatives, it's the opposite of positives. And then we would put a closed circle on negative 3 this time. And again, since x is less than negative 3, we would shade the numbers less than negative 3. So again, if we plug in a solution, negative 5, that's less than or equal to negative 3, and that's a true statement. So let's do one with a fraction now. We still subtract 2 on both sides. So we would have 1/3 x is less than 3. And then we divide both sides by 1/3. When we divide by 1/3, it's the same as multiplying by 3, so x is less than 9. So we label our number line. And this time we're going to put an open circle on 9. And again, shade to the left. So again, if we check our work, 8 is less than 9. That's a true statement. So on our next one, we can, again, start by, this time we're going to add 4 to both sides. So we have negative 2x is less than or equal to 10. Then we have to divide by a negative 2. And when we divide by a negative, we flip the sign. So x is greater than or equal to negative 5. So on our number line, we have negative 5 in the middle, and then negative 4, negative 3, and then negative 6 over here, and negative 7. And this time we're going to use a closed circle because it's greater than or equal to, it has that line underneath it, so we have to use a closed circle. And since x is greater than negative 5, we're going to shade to the right. We're going to shade the numbers bigger than negative 5. That's the end of the notes for benchmark 19, solving inequalities. If you need to go back and rewind and watch it again, please do so. And make sure you have all the examples written down in your notes.